In this video, we're going to be exploring how programmers can make their code more maintainable. Writing maintainable code is really important because sometimes when you write programs, you might finish them and then have to return to them perhaps many months or years later in order to add new features. And when you do, and you open that code, you might not understand how you programmed it if you didn't use appropriate techniques. Also, when you're working in teams, it's really important that other programmers in the team can pick up your code and they can understand it, and they can work with it really easily. Here we can see a program that hasn't been well maintained. It hasn't been written as well as it could have been. The first time you look at this code, it's not obvious really what this code even does. We can see that it inputs two numbers, but what does it actually do with those numbers? What does it actually achieve? It would be hard even for an experienced programmer to have a look at this code and understand quickly what it's actually doing. So we need to improve this program in a number of ways. We can instantly see here this is exactly the same program. We've just shortened it a little bit to focus on the key aspects of what we're trying to demonstrate here, but instantly it looks a little bit more readable. We're using comments in order to separate sections of code so we can see where one function starts and another one ends. We can also understand what's happening with these functions. So if we take the first example, we can see the purpose of function GCF_OF is to find the greatest common factor of two input lists. We can also see throughout the function how the programmer has commented the code to explain what different sections of the code achieve. We don't have to comment every single line of code, just sections, so it's easy to understand what's going on. And we can see that this approach is common throughout the program. We can also observe that the functions and the variables are being given sensible names, so they actually refer to the kind of data they're storing, and we're avoiding using single letter variables. We're also indenting our code. Now, of course, with Python, you have to do that, otherwise you're going to get a syntax error. Other languages and IDEs will actually spoil you a bit by automatically indenting the code. But there are many languages out there where the syntax of the program doesn't require the code to be indented, but it's still considered very good practice for you to do that. So let's just recap what we've covered. You can use comments to explain the purpose of the program, explain sections of code, typically selections, iterations and procedures, explain unusual approaches that were necessary, and visually divide sections of a program. You can use white space to make sections of a program easy to read. Use indentation for every selection and iteration branch. Use descriptive variable names and explain their purpose with a comment when declared. Use procedures and/or functions to help structure your code and eliminate duplicating code. And use constants declared at the top of a program.